And greetings, friends around the world and enemies, unfortunately. I'm going to try to tell you in a brief, general manner why the United States should not have its energy program impeded in the least. That if you consume electricity generated by coal or propane, or if you drive your large truck with gasoline or diesel fuel from petroleum, I say have at it. Burn all you want. You know, put as much carbon dioxide as you can. If we went on a binge and tried to choke the Earth's atmosphere with carbon dioxide, I don't believe that we could add a significant amount. If we were able to, the result would be positive because plants are starving for CO2. And farmers would thank you for putting more uh, CO2 in the atmosphere, which is used by plants through photosynthesis to make carbohydrates, whether it be cellulose or wood or starch or sugar. Some people would tell you that we must not put carbon dioxide in the atmosphere because it absorbs and reflects infrared light. Got bad news for you. I absorb and reflect infrared light. The mountains absorb and reflect infrared light. The ocean absorbs and reflects infrared light. Everything on this planet absorbs and reflects infrared light. So what? Carbon dioxide obviously does not drive the climate cycle seen plainly on Al Gore's Vostok ice core chart. This cycle occurs at intervals of 110,000 years and has been doing so for at least the past million years or longer. The temperature of the planet rises and CO2 rises consequently because CO2 is exhaled from warm water. CO2 dissolves in cold water. The leftards who want to cripple the U.S. economy have no basis whatsoever in science. I'm going to tell you what does drive the climate. I'm going to illustrate, first of all, how far away the sun is. If you got in a military jet plane that was capable of going 500 miles an hour over a long distance, some passenger planes can do that. But if you were to fly one of these fast planes to the sun, going 500 miles an hour, how long would it take you to reach the sun, or to go that same distance as the sun is from the earth? You can take 93 million and divide it by 500 with a calculator, and you get the number of hours it would take. It's a large number and it's rather meaningless, so you can divide that by 24 and get the number of days it would take. You suppose it would take you a week to get to the sun? No, if you divide the number of days by the number of days in a year, 365, you might be surprised to find it would take you more than 21 years to reach the sun. The sun is much further away than we intuitively suppose just by looking at it when it rises in the morning over the treetops. The nearest star, which is too faint to be seen with the naked eye, and is actually a small cluster of stars, Alpha Centauri, is 4.4 light years away, meaning that it takes 4.4 years for the light to reach the Earth. The light from the sun, on the other hand, takes only 8 minutes. Other stars and other nebula, objects that could be seen with telescopes, are hundreds of light years away. These stars are gravitationally associated in various ways. They move around. They're in movement, just like the moon is orbiting the Earth, and comets orbit the sun and move through the galaxy, probably from star to star in some cases. All of these objects in space, which are very huge but very far apart, are in motion. They're so far away that we don't notice any change in the constellations when we look up at the sky. They appear to be unchanged because these objects are so incredibly far away. It's an illusion. It fools the human eye because light goes on and on and on and on and on until it finally hits something that it can't penetrate, and it can very easily penetrate great distances in space. It is somewhat diffused. The light from stars is somewhat diffused when it passes through a dense area of interstellar medium called a nebula. And a star that's inside of this big cloud of gas, dust, illuminates this cloud so that we can see it. That's how we're able to see it. The cloud of dust is lit up from within by one or more bright stars. Glistening along the spiral arms of the galaxy, bright emission nebulae mark regions where new stars are forming. If the sun were to move through a nebula, it would receive sustenance. And burn more brightly, slightly. It would be slightly brighter. And if it remained in this cloud, this nebula, for hundreds of years, which it likely would because these nebulae cover vast regions, several light years across, the oceans, the Earth's oceans would slowly warm from that increased solar output. The ice caps would slowly melt. And the glaciers on mountaintops would slowly melt. And then as the sun moved out of this thick nebula, it would burn less brightly. The ice cap would grow, and the ice, the snowpacks on the mountaintops would increase. The overall temperature of the planet would decrease, and we would have entered another glacial period. And these glacial, interglacial episodes are plainly visible by a cursory glance at Al Gore's famous Vostok ice core chart. And it occurs in a predictable, repetitive, cyclical way, as though the sun was orbiting another star again and again and again.